All right, welcome back. So in the previous videos, I was starting to look at refraction and reflection, but there was an issue. And the issue is that when my ray came and hit a sphere, it refracted, okay, but really what I should have done is identified the point where it exited the sphere and then refract it back in the other direction to make it physically accurate. So that's basically what I'm going to look at today. It should be nice and quick. Let's do it. So the issue of whether the sphere is inside or outside of the ray sort of comes down to the ray tracing equation. Let's say we have a sphere with an origin and a direction, and we trace it out. Points of intersection are the roots of the quadratic equation, and we know that a quadratic equation has at most 2 roots. I'm just going to denote these T1 and T2. So far, everything I've been doing has been just determining visibility, which really we only care about being outside the sphere and identifying the first intersection point. So T1, if we look at the quadratic equation, would be something like, minus b, I swear I can do math, minus the square root of the discriminant over 2a, and T2 is a larger value of t, that is the following. So previously in our intersection test, we were simply testing the first of these 2 values and working with that. Now I'm going to write a modified intersection test, which also considers the second value, and if the first value is outside of our viable range, then we inspect the second value. And this would work in the case where we go ahead, we intersect the ray, and then we reorient the ray after a refraction, go ahead and shoot out. In this case, the T1 of this quadratic equation would fail, whereas the T2 of the quadratic equation would succeed. And that's nice, because we can then determine intersection points from the interior of a sphere, which is all well and good, but there are just some weird edge cases that I need to work out. And I will admit that what I've got at the moment is sort of in an uncanny valley of ray tracing. Like, it's more physically accurate than it was before, but there are still some things which look a little strange. Personally, I'm okay with that because I'm working within the constraints of real-time rendering. But let's investigate these cases. So typically when we shoot along and we hit a sphere, we've been spawning 2 rays. We've been spawning a reflection ray and a refraction ray. And that's all well and good in the case when the sphere is going from a less dense medium into a more dense medium. As a matter of fact, I'm not sure how much physics experience you have, but there's an analogy with a spring where when we have like a wave going through a spring or a string or something of low mass into a spring of high mass, then the low mass spring experiences a reflection as well as there's a transmission through the high mass spring. And that's sort of similar here, because the point I'm getting at is, on the other hand, when we're a ray of light inside the sphere and we hit the boundary, we only want to refract. We don't want to then spawn a reflection ray inside the sphere. It creates some weird effects. As far as I can tell, it's not physically accurate to perform that behavior, but maybe it is, I wouldn't know. It is reasonable to say, why don't we simply, when we know that we're spawning a refraction ray or modifying a ray for refraction, why don't we immediately at that point calculate the intersection point, move to there and continue? And the reason for that is I want a general system which will work later on if I want to load in models from files and things and deal with general triangles. There's not a nice form to immediately calculate the exit point for the ray. I guess I'm almost done here, but let's say, for instance, we come along, we're at depth 0. These 2 rays are spawned, both with depth 1. What I want is, I want to make sure that this refraction ray keeps its depth of 1 while it's inside the sphere. And so once we come out, I'm not going to modify the depth. In the case that we are refracting from the inside of a sphere to the outside, probably time for us to look at the code. Okay, so here's our code from the last video. I think it's just good to have a reminder of where we've come from. At the moment we have these spheres. They look sort of glassy, sort of reflective. To be honest, they look okay to me like this, but let's improve it. So I'm just going to close this down and we're going to have a look at the shader, and I'm going to try to follow the logic from top to bottom. So we are going to need to modify our render state so that our render state measures whether the last ray intersection occurred on the front face or the back face of a sphere. Then when we're spawning a render state, we probably don't need to change those default values because, well, they'll be changed by the hit function. So we'll go down, get rid of this for the time being, go down to the sphere intersecting code. And here I've got T. I'm just going to modify this. Whoops. I'm going to call that T1. And I'm also going to calculate T2. Awesome. So now I'm going to test whether T1 is within our acceptable range. And if it is, then we will read that off as the intersect time, and we'll just set the backface value to false because this is an intersection with the front face. And then on the other hand, if it's T2, which is within our acceptable range, then no problem at all. We can just record that, and that is a backface. And there we have it. That's all that needs to change. So I'll go ahead and leave that. And now in the main function, I'm going to, I'm just going to also make a modification to the ray struct. In addition to the depth, I'm going to have a flag which just tracks whether the ray is done. And this will be useful in some cases when refraction fails. I want a ray to immediately stop. So I'll leave that, and then I'll go down to the main function where I start off my ray, and of course I don't want that ray to stop. And I'm just going to make a few minor modifications in the rest of my main code. So at the start of this loop, currently I'm testing the ray's depth. I'm actually just going to test the ray's early exit parameter and work with that. So that's all fine. If the ray has to end, then the ray ends. Down here, I will attempt to trace, and okay, I have a ray, I perform this scatter operation, and I'm not going to modify the depth. The depth will actually be modified within the scatter function, and potentially, as in the diagram, potentially we could be coming from inside a sphere, in which case we do not want to spawn a reflection ray. So to check that, I will inspect the reflection ray's early exit parameter. And I will only add that reflection to the stack if it has indicated that yes, it is intended to be traced. Okay, so this lets us optionally spawn that reflection ray. The rest of this is fine. Yeah, that's all fine. So I'm going to leave that and have a look at the scatter function. Okay, so what I'll do is I will, actually, I changed my mind. This is fine. This is fine at this point. But now what I need to do is I need to determine whether to spawn that reflected ray or not. And the way I'll do that is I will test the render states backface variable. So if we're shooting and we're hitting a backface of a sphere, then one thing's going to need to change. The normal is going to need to be flipped around, because the way the normal is usually measured by this formula would be from the center outwards. We want to have the other side of that. And then I will go ahead and run the refract ray operation. But I'm going to put in a Boolean variable to indicate that we are hitting a backface. And I'll do the same thing here. And the reason I'm doing that is to indicate which refraction index to use. Now, the last thing I'm going to need to do in this branch is I want to indicate that I'm not going to spawn a reflection ray. I'll do that by signaling the early exit parameter, and I can go ahead and return. Okay, so on the else branch of this, I'm going to do my usual reflection and refraction, and I'm also going to increment the depth of the rays. So I'll take my refraction depth, increment it by 1, and optionally indicate that the ray should end. Great. And then I'm going to do the same thing with the reflection ray. So, of course, the reflection ray's depth is going to need to be the same as the refraction ray's depth. These two come as pairs. And if the refraction ray is going to end, then I want the reflection ray to end as well. I just changed my mind because I thought of a case where the refraction ray may end, but I don't want the this is the one thing I don't like about this topic, is there are a lot of little edge cases. So let me try to explain this. If I shoot in my refraction ray, but it's just a bad condition, it's ill-conditioned or something, it's going to have a case of total internal refraction or reflection, I guess, then yeah, I totally want the refract ray to just terminate. But it's possible that although the refraction ray is going to terminate, the reflection ray still could continue. And so for that reason, I don't want to copy this variable directly. I want to... Wait, why am I... Oh. It's been a long day. It doesn't help that those variable names have the same number of letters, but as you can see, I'm just doing the same logic. I hope that makes sense. All right, so now I've modified my refract ray function so that it takes another parameter, which is the whether we're hitting a backface or not. And so I'll just change that in the declaration up above. And I'll have a look down below as well. Okay, so at this point here, I'm going to make some modifications. I'm going to have a parameter eta, which, as you'd be aware, is measuring the ratio of refractive indices. Now, eta typically is the index going from air into the glass of the sphere. And so if the backface option has been set, then I want the reciprocal of that. So 1 over the sphere's index. This is the refractive index, which represents moving from glass into air. Otherwise, it will be the original, which is moving from air into glass. Okay. So the next thing I'm going to do is I'm going to work with this, but there are some cases. So with the refraction function in GLSL, if it fails, it returns a vec3 of all zeros. So what I'm going to do is I'm just going to call that function first of all, and then I'm going to measure the length of the result. And test that. So I want to see basically, is the result, why can I not speak? Is the result 0? Now, if the result is 0, then we're done. But if the result is not 0, then we will simply normalize that. So we'll take over the ray length and scale the direction by that. So I know that I've gone through a fair bit, and in a sense it has been sort of do this, do that. So What I'll do is I'll run this right now and then I'll step back through the code. Not the least of which is look for errors, because they happen often. Haha, okay. What do we have? Alrighty. 33. Oh yeah, bool equals early exit. What's going on there? Just a bit of fun there. That should be reflection ray. I hope this is it. Undefined variable. Backface. What did I call it? Oh, I just forgot to put something in there. Guys, it's not exciting coding. 90% of it is bouncing off the walls. Case in point. So this would seem to indicate to me that something is not being set because it seems to be filling with random values. Although refraction is working. Okay, let's take a bit of time to inspect this. Actually, on second thought, I think I know which variable was uninitialized. When I spawned the reflection ray, I based the reflection ray's early exit parameter on its own early exit parameter. So that is slightly dodgy. What I'll do instead is just base it purely on its depth parameter. So let's now give that a go. All right, there we have it. So like I said, we are sort of in the uncanny valley now, where although this is more physically accurate, it looks strange. That's just the fact. But if I look here, I can see that, yep, there's that sphere in the center of my screen. It is now visible through that other sphere. So refraction is working more accurately, I would say. And this is another cool thing. I can actually now hop inside spheres. Sort of funky. I'm walking backwards because of the curvature, I guess. I don't know. I've never existed within glass before, but I have worn sunglasses. Sort of looks like this. And you'll also note we have these, they look like air bubbles. And these are spheres which are just reflective. They do not have a high transmission amount, so they look like whatever, but then when we hop inside, they have different colors. I don't know, this is pretty cool, right? Well, anyway, there we have it. There's been our little bite-sized chunk. Oh, Andrew from the future here. I just remembered I said I was going to run this and then talk through the code. I just got so excited playing with the spheres. So let me walk through this. What we did is we needed to store a little bit of extra state. In our render state, we needed to store whether we hit from inside or outside a sphere. The reason we needed to do that was that when we're traveling from out of a sphere, from inside a sphere out into the air, the refraction index is, we take the reciprocal of it, and also the normal has to be flipped around, because that calculation for the normal is typically from the center out. Okay, I also added another parameter so that when a ray is inside a glass sphere and it's doing total internal reflection, i.e. the refraction will fail, it can signal that it's not going to work, and also so that when a ray refracts from inside a sphere, it can signal that it's not going to spawn a reflection ray. So those are the modifications I made. Then the hit function was surprisingly simple. All I needed to do was, instead of testing one t parameter, simply test both roots of the quadratic equation. Then when it came to hitting, it was a little bit more complicated. Everything's set up as normal, except that if we are coming from inside a sphere to outside, we only spawn a refraction ray, as opposed to the other case, where we're hitting a sphere, we spawn both a reflection and a refraction ray. And apart from that, really, the devil's in the details. Code is linked down below, and you can check it out. We have more accurate refractions and reflections. So there we have it. In the next video, I'm going to leave the light modeling for a while, and I'm going to have a look at, I want to hop inside this red one. I'm going to have a look at sort of refitting the acceleration structure. It's cool. Anyway, so I hope to see you there, and I hope everything's going well. All the best. Keep coding. I'll see you again soon. Bye.